So, what's this about? This is about relativity theory in many ways. So, we've got Einstein's classic E equals mc squared function, which is a bastardization from an original engineering equation, which is E equals half mv. So it's half of the mass multiplied by the velocity, comes up with a value of joules, or like a particular amount of potential energy and kinetic energy. And Einstein bastardized that to replace an unknown quantity v of velocity with a known quantity of velocity, which he calculated to be c, and he valued a fixed light speed. Then he uses the square of the velocity, and he uses the total mass rather than half the mass. So in that way it becomes exponential, infinitely exponential, so that on a mapped graph, mv, E equals mv would be this, yeah? E equals mv squared would be like that. So, and E equals half mv would be like that. So you get these different angles of propagation. So Einstein's work on that was really nothing more than just substituting a known velocity for an unknown velocity. Tesla makes an awesome note, Nikola Tesla, in one of his workbooks, again from the Colorado Springs experiments, where he theorizes what is the actual value of v in the engineering equation if you have the energy equals half the mass multiplied by the velocity, and you've got the total mass of Earth. Yeah. So assuming a spherical Earth moving in a geocentric model around the sun, you've got the total mass of Earth and all the mass of the humans, the animals, and everything on it. Yeah. So that's already got a particular joule of energy value that you could calculate, because you could say that the Earth is rotating, but in order to calculate the energy that Earth potentially has in joules, in terms of its ability to impart energy through its mass, through force, you would have to come up with a known velocity for Earth through space. So Tesla theorized that, he made a little stick model. So if Earth is rotating not only in its own spin, yeah, so centrifugally from the center of itself, but also around the sun. But the sun is rotating around the galaxy, the center of the galaxy. So if the Earth is being propelled around the sun at a certain given rate, velocity, and the sun itself is being propelled around the center of the galaxy at a given velocity, and the galaxy itself is being propelled around the center of the universe, and so on and so on and so on and so on. And his theory was that it would either be an impossible calculation for the actual velocity of Earth, or it would have to be the maximum permissible speed already reached, so that the Earth and all the matter of Earth is potentially already moving at light speed because it's being shot through the universe at light speed in this enormous, multi-armed swing experiment, if that makes sense. So then he said, potentially, the entire of Earth already is moving at light speed. So then everything that moves beyond that velocity, if you think about it, if this T-tail and I are both moving at that maximum velocity because we both just exist on Earth and we're being shot through the cosmos, then if I can throw the T-tail at a faster rate than because I'm not moving in relationship to that, on some level, can I throw the T-tail faster than the velocity of light? Because the T-tail is already moving at the velocity of light. And his theories for that were awesome. So it's if you could cause the velocity of an object to slow in relationship to the world around it, so if the Earth is already being propelled at light speed, could you use magnetic fields, or could you use call them subelectric fields to isolate matter and cause the velocity of that matter to slow down in relationship to the world around it, if you could cause that field to not be attached to Earth? So if you could put the T-tail in a bubble of itself that exists just outside of Earth's rotational influence in space, then would the T-tail simply actually move backwards in time, because Earth would still be moving at light speed in relationship to the T-tail? Yeah? Really cool ideas, really cool functions. But the thing to take away is Einstein's work was not particularly great, at least on that function, that he adapted into a usable form, but I still think that there was an incorrect adaptation in itself. Relativity itself demands that there's only a motion of energy through entropic forces from a point of energy, a high point of energy to a low point of energy. So the laws of equilibrium apply, if I want to calculate the total rate of flow, so I get a Joule value for energy of water moving through a water tank, I need to have a destination for the water. I can't just have only the starting point and then nothing else and come up with a determinable value for the flow rate of water or the amount of energy that the water could impart. So if I have like a ball, right, or let's say I pick up this thing, and if I was to throw this at the pillow, let's just say that I calculate a value for the joules of energy of this object by stipulating that it weighs 1 gram and I'm going to throw it at 1 meter per second, So I could square the velocity of that, multiply it by the weight, and I could come up with a function in joules, in values of energy, for the total amount of potential energy that it could impact into or impart through force. But there's a problem with that, because the function is assuming that the thing that it hits is moving at rest or is still. Because if the object that it hits is also moving at 1 meter per second and also weighs 1 gram, then the two objects can never ever meet. Yeah? If they're traveling in a particular linear vector, if they're traveling in a direction which is going to collide, then I will have far more. I'll have a multiplication, a doubling of the energy impact. So it would be impossible to say that this has an energy value of X. I would have to only say this has an energy value of X joules in relationship to the pillow, which is moving at blah, 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 blah. So does that make sense? Like if you're running and I have a tennis ball and I hurl the ball at you and you're running at 1 meter per second and I hurl the ball at 1.1 meters per second, eventually the ball will catch up to you, and if it weighs 100 grams, the total amount of joules of energy that it will impart to you will only be relative to the amount of time it takes for it to slow from 1.1 meters per second to 1 meters per second. Because when you and the ball are now moving at the same velocity, there's no more imparting of energy. So it would be pointless and useless to calculate the value of the infinite light speed of the ball's potential propagation velocity multiplied by the mass, or the square of that multiplied by the mass of the ball, and then say this tennis ball could represent 200 trillion joules of energy. But that would only be, I'm just making that number up. That would only be true if you were moving at total rest in the universe. And we know that that's not the case. And so then I think really the equation, the function, should be in, sub-entries like brackets, that the 0.1 E equals mc squared minus 0.2 equals mc squared would give you a value of the actual energy transfer available. Does that make more sense? Like another example. So like if you've got two pieces of metal, two pieces of metal. Let's say that in a perfect idealistic world of theory, they are completely identical in density, shape and type. Yep. So these two plates of metal are completely identical in every possible way except for the temperature that we heat them to. And somehow, because it's a hypothetical, we are able to put them into a completely isolated, non-entropic area in terms of them bleeding energy to other forms like air particles or the surrounding space. So let's say that we'll only ever get a transfer of net energy from one to the other, and it's not going to be lost to heating up the air around it, for theory. If I heat this one to 100 degrees Celsius, and I heat this one to 90 degrees Celsius, and I have some form of measure of meter that would allow me to see in joules the value of energy transfer over, let's say, an hour, I would expect to see a total of 5 degrees of displacement between the two because of the law of equilibrium. So the higher energy state metal at 100 degrees would give energy through entropic forces to the 90 degree piece of metal only until the two are at 95 degrees. And then there will be no more transfer of energy. Yeah? If I put the same piece of metal at 100 degrees and I put a piece of metal at 0 degrees and I measure the same amount over an hour, I would expect to see 50 degrees worth of total energy transfer. So we could say that the hot piece of metal doesn't really have an inherent energy value of potential energy. It's only in relationship to whatever the energy is going to be flowing to. So I don't think that we can say that from Earth, that galaxy is X distance away, because we would have to know for certain that the velocity of both Earth and that galaxy were identical. And that and then like applying into the function, the mass of those bodies, to then be able to view that back with like redshift and blue shift of light wavelengths, and how we use that as a value to say, oh, those stars are moving away from us, those stars are at a certain rate, the Earth is catching up to those stars because it's shifted to the blue side of the spectrum and the wavelength has shortened, etc., etc., etc. So there's a whole bunch of problems with those functions, yeah? Like, I think they could work, but Einstein's equation as it is now requires you to assume that everything else is not moving in the universe, or that everything else is moving at the exact velocity that we are as well. And that's just ridiculous. Like, why would the universe move at an identical velocity? We can even show that light speed isn't constant on Earth, let alone in the rest of the cosmos, So there's my issue with Einstein's relativity theory.